So I could not find a single YouTube video on static dual analysis at all. So I figured I would just make one real quick because it'll help me to understand what's going on here. But first, so let's go over scheduled and let's do unrolled, right? So we're going to be given C code, and with that C code will come some RISC-V code that should be given to us, right? Now, what are we doing here? Essentially, we're writing out the steps of the pipeline as they come in. If we're able to load something per cycle or add in a cycle, then we write them down, and if not, we say no operation because we were unable to do that. This is almost the same as writing out the table, but you're writing out the steps that you're doing instead of the steps that are happening, so it's like a different form of that. So to start here for unrolled, what are we going to do? We're going to do our first operation up here because we're only doing one iteration of it. That's what unrolled is, right? We're doing one iteration. So first what we're going to do, we are going to load word x31 020, right? Now that is our first cycle. Our first question now is, are we able to do an addition or an ALU or branch operation in the same cycle that we're doing load word? Because currently we have an add I. Let's see. I actually wrote this down wrong here, but we have an add I 4, right? Where we're changing that, we're changing x20 by 4. So can we do that while we're currently using x20 in load? The answer, no. So we're unable to do that in cycle 1. So that means we have to write no operation for the ALU, then we go into cycle 2. Now for cycle 2, are we able to do the operation? The answer, yes. But do we have another load or store operation ready right now to start? Because we would start with that. The answer is no, we don't have one. So we write no operation for our load and store. And then we go over here to the ALU and we're able to do an add. So we write that down. We're able to do the add I x20 x24. Now we go to the next iteration, right? Which would be cycle 3. I mean, not iteration, cycle. Are we able to do an addition? The answer is yes. But again, we have to ask the same question, which is, do we have a load or store operation to do currently? The answer is no, so we write no operation here because we don't have one to do at this moment. And now we do addition. And do our x30, x21, x20, right? It's badly written, but it's there. So now we go to our next step. Cycle 4. Okay, so do we now have a load and store operation that we want to do? The answer, yes. We have store word. So what are we going to do? We're going to write store word here. That's x30. My handwriting's so bad here because I never use this pencil, but now on our ALU or branch, do we have a branch operation we want to do? That is correct, we do. So we have a BLT, and we are able to do that. And that is one iteration of unrolled on this code. And you would follow code like this no matter what kind of code it was, right? So now how do we get the number for it? Well, there's a total of 1, 2, 3, 4, 5 total problems. I mean, lines of code. So that's 5. And you divide that by the cycles that we did, which is 4. So 4 divided by 5. And I may have done that backwards. So let me just put that in a calculator real quick because pretty sure I did that backwards. No, I didn't do it backwards. I don't know, I was overthinking it. It's been a long day. Anyway, 1.25. And that's our IPC number. And that's how we do the unrolled version of that. So then let's go to rolled, and let's do 3x, right? Now, for this rolled 3x, we're going to go down this code.